This video I'll be talking about torque on a dipole in external electric field. Torque on a small dipole in an external electric field. Okay, so understand this point is very important. Suppose that we have a small dipole like this, which has distance 2L between them, and suppose that there is an external electric field is present. External field. Now understand, currently if you see the forces, then there will be force QE in this side, and of course this is negative charge, so that would be QE in opposite direction, right? So as of now we will not be able to achieve any torque. So what we have done, we have rotated this dipole with a certain angle theta such that we are able to see the phenomena of torque developed. So suppose that we have dipole like this, minus and plus. So of course you know that this QE force will be this side, and of course this QE force will be developed in opposite direction, right? So this is the force. So of course I know that if this length is, let's say, 2L, then this is the common center of mass. If this is the common center of mass, then here we are observing a phenomena of force couple, right? Force couple means when two forces of equal and opposite magnitude are acting, then F net will be 0, because clearly you can see that QE in positive direction and minus Q in opposite direction, but there will be certain phenomena of torque. So we want to achieve that torque. So clearly if this is the common center of mass, let's say O, then this length is going to be L. So we can draw a perpendicular here and also here. If this angle was theta, so we can clearly observe that torque about point O, torque about point O is equal to, that would be given by F electric, this QE is F electric, so F electric into, so the formula of torque is R cross F, right? So first of all I need to write R perpendicular cross F electric, right? The value of F electric, basically magnitude, Fe is Q into E, this is the magnitude, and R perpendicular, vector R perpendicular, so here this is L. If you see this triangle, right, so in this triangle this distance will be the perpendicular distance, right? So perpendicular distance is this distance, so we can eventually write it R perpendicular into F, right? So we can also write, if we want to write the magnitude of torque, right, magnitude of torque can be written as R perpendicular into F, and the value of R perpendicular is nothing else, L sin theta. In this triangle this will be L sin theta. So value of torque is equal to QE into L sin theta, correct? Now basically this is because of one force, right? So we have how many forces? We have two forces. Because of this negative force also, opposite direction also, that would also give us QEL sin theta, correct? So what do I achieve then? So we achieve net torque is equal to 2q E L sin theta. So we can write it as 2q into L into E into sin theta, correct? So this is going to be the magnitude, and we know that. How do we define dipole? So dipole is defined as q into 2L, correct? So we can substitute this value as PE sin theta. So this is the magnitude of the torque, and we know that if this is the format, then vector tau will be equal to PE sin theta and n cap. N cap is the unit vector. This is for direction of torque, which can be written as P cross E simply. We know in vectors this is P cross E. So that's how we calculate the torque in electrostat. In any dipole, external electric field is present. Okay, so you need to remember this formula. This will also help us in order to calculate the potential energy of the dipole system. Okay.